Hi, this is Mrs. Freeman, and today we're going to talk about adding and subtracting polynomials. Before we add and subtract polynomials, we have to discuss a few terms. So the first sentence on your note says, like terms are defined as having the same variable and the same exponent. So a variable, remember something like x, y, a. It's a letter that represents an unknown. And they have to have the same exponent. So if we had x squared, the 2 is your exponent. Then it says when adding and subtracting polynomials, you add and subtract like terms. So 2x squared and 5x squared are like terms because they both have the variable x and an exponent of 2. Now 2x squared and 5x, though, are not like terms because they have the same variable, but they do not have the same exponent. Okay, so when we're adding and subtracting, we're looking for like terms. Same variable, same exponent. We have 4 steps when we add and subtract polynomials. Our first step is to distribute any negative signs. So remember, distribute just is when you have to multiply. So if you have some number outside of a set of parentheses. Second step was we want to get rid of the actual parentheses. 3, we're going to combine our like terms. So remember that's something like 5x squared and 2x squared. And our last step is that we're going to write our answers in descending order. So that means that when we look at our exponents, they go in order. So this would be in descending order because we have an exponent of 2. This means an exponent of 1. And here we don't even have an x. Okay, so let's look at the first example. We have the quantity of 12m squared plus 4 plus the quantity of 8m squared plus 5. So if you go back and look at the steps, the very first step was to distribute any negative signs. Well, if we look at this problem, we don't have a negative sign because we're adding here. So that means we can just drop our parentheses and rewrite our problem. So we have 12m squared plus 4 plus 8m squared plus 5. There was nothing to distribute. So now we're going to look for like terms. So this first term is an m squared. So we're looking for something else that has an m squared, which would be this 8. So right in front of it says we're adding 8m squared. So 12m squared plus 8m squared. So you add the constants, the 12 and the 8, which is 20, and we leave m squared. Now our other like terms are our constants. We have a plus 4 here, and we have a plus 5. So 4 plus 5 would give us 9. And that's a positive 9, so we're adding it. The last step said that we want to write in descending order. So we have a variable of m, and our exponent's 2. We don't have any other m's. This 9 doesn't even have an m. So this is our final answer. So example 2, we have the quantity of 6s squared plus 3s plus 7 plus the quantity of 2s cubed minus 6s minus 4. So once again, our first step said to distribute our negative sign. Distribute if we need to. So if we look between the two sets of parentheses, though, we have an addition. So there's nothing to distribute here. If you distribute that plus sign, you're not changing anything. So we can just drop our parentheses. So we have 6s squared plus 3s plus 7. So I'm just rewriting this without parentheses, plus 2s cubed minus 6s minus 4. So I'm going to look for like terms. So I'm just going to start with the first one. So 6s squared. So we're looking for anything else that has an s squared, which we don't have anything else. So we'll just bring that down. Okay. The next term has a 3s. So let's look for anything that has a plain s, which over here we have a negative 6s because you're using the sign in front. So 3 minus 6 would give us negative 3s Okay, here we have a constant, a plain number, so 7, any other plain numbers down here at the end. And that one's a negative 4, so 7 minus 4 is 3, but that's a positive, so we have to put a plus in front of it, plus 3. Then we have one number left here. Notice we have this 2s cubed. Well, there's nothing that matches that, and it's a positive, so we're just going to bring it down. So plus 2s cubed. Now our last step, though, said that we need to write them in descending order. So if we look for descending order, you're going to look for the biggest exponent on your variable. So the biggest exponent would be this one at the end. This one has an exponent of 3. So, and that's a positive 2s cubed. So that one's going to go first. Then let's look for an exponent of 2, which would be this one up here. So this 6s squared. There's not a sign in front of the 6, so that means it's positive. So we're going to say plus. So exponent of 3, exponent of 2, so exponent of 1. That would be this one right here. This is minus 3s, negative 3s. So exponent of 3, exponent of 2, exponent of 1. No exponent would be this last one, so plus 3. 2s cubed plus 6s squared minus 3s plus 3 is our final answer. Example 3, we have the quantity of 2x cubed plus 4x squared minus 6 minus the quantity of 5x cubed plus 2x squared minus 2. So step 1 is to distribute any negatives here. And if we look, this one has your negative. This one you're subtracting. So you're subtracting this whole second set of parentheses. So that means you have to distribute this negative throughout the second set of parentheses. This is like distributing a negative 1 here. So that's what we're going to start with. So I'm going to distribute this negative 1. So negative 1 times 5x cubed. Negative 1 times 5x cubed is negative 5x cubed. Then I'm going to distribute this negative 1 to this 2x squared. So a negative times a positive makes that a negative 2x squared. Then I'm going to distribute that negative 1 to this negative 2. A negative and a negative makes that a positive 2. So notice what it did, it switched all the signs on the second set of parentheses. Then I'm just going to bring this first set of parentheses straight down. So on the first set of parentheses we have 2x cubed plus 4x squared minus 6. So remember, now we're looking for like terms. So I'm going to start with the first one. So 2x cubed. So do we have any other x cubes? And we do right here, a negative 5x cubed. So 2 minus 5 will give us negative 3. Leave the x cubed. Okay, and then let's look at the next term. So 4x squared. So do we have any other x squareds? We do. A negative 2x squared. So positive 4 minus 2. That will give us positive 2x squared. And since it's a positive, we're going to put a plus in between them. Then we have a constant here, a negative 6. So any other constants or plain numbers, a positive 2. So negative 6 plus 2 is a negative 4. Look and see if they're in descending order, which they are, because you have an exponent of 3, an exponent of 2, and no exponent on the end. So your final answer is negative 3x cubed plus 2x squared minus 4. So last example, we have the quantity of 8c to the 4th minus 2c plus 3 minus the quantity of 3c squared minus c plus 1. So the first step was to distribute any negatives, which we're going to have to do on this problem because you have a subtraction problem. That's our negative, which once again means that you have like a negative 1 that you're distributing. So we're distributing just to the second set of parentheses. So negative 1 times 3 is negative 3. Bring down the c squared. Now this minus c over here, this is like a negative 1. So when we distribute, we're distributing negative 1 times negative 1. A negative and negative is a positive, and that will stay 1. We'll put the c with it. And then a negative 1 times a positive 1 makes that a negative 1 at the end. So once again, what's basically happening when you subtract is you're changing all the signs on the second set of parentheses. And we'll just bring down the first set straight down without any parentheses. Then we can start to look for our like terms. So let's start with the first term, 8c to the fourth. So we're looking to see if we have any other c to the fourth, which we don't. So that one's going to come straight down, 8c to the fourth. Then I'm going to go to the next term, so plus 2c. So any other plain c's, which we do. So we have 2 plus 1, which will make that 3c. And since that's a positive, we'll put a plus. Then we'll go to our next term, which is positive 3. So a plain number, a constant, and we have one of those at the end. So positive 3 minus 1, so 3 minus 1 is 2. And since that's positive 2, we'll put a plus sign there. And then our next term, we have a negative 3c squared, and that's the only thing left. So we'll just bring that down, negative 3c squared. Now our last step is that we need to write these in descending order. So we're going to look for the biggest exponent. So our biggest exponent would be c to the fourth. So we're going to start with that. So 8c to the fourth. Let's see, we don't have any exponents of 3, so we'll go to an exponent of 2 next. So minus 3c to the second. An exponent of 1 would be this plus 3c. And then no c at all on the end, so plus 2. So descending order, our final answer is 8c to the fourth minus 3c to the second plus 3c plus 2.